So, just to say, the compiler is your friend, okay? Whichever compiler you've got, it will give you some help. These reports tell you, as we said, which parts are and are not vectorized. And as we've also now discovered, also ignore the bits that it gets rid of by the looks of things. So if you don't see something in there, one of your loops, maybe it's not actually necessary because it's already been got rid of. As we said earlier, combining this with a performance tool to say this particular part of my code is really intensive, and then getting the vectorization report allows you to know where you should concentrate your efforts. But ultimately, once you've done all that work and get the big wins, you really should try and go through and get good vectorization elsewhere. Particularly as we move to these wider and wider vector units, such as we'll be seeing on the Intel mic, because it's just another version of Amdahl's law to some degree. Okay? If you can speed something up by, say, 8 times, because you can vectorize it, well, now that thing that was only taking a quarter of the time is now the most expensive. So you have to still keep going through, just like if you do multi-threading and so on. Vectorization is very much the same. Okay? The only difference being that people are normally in our business more interested in the scalability. And once they've got a reasonable performance, they can get the allocation time on the big machine. They don't necessarily go all the way as far as they should. Okay, and so that's just a simple example. You're unlikely to get the full speed up. Okay, so if the vector is 8 times what you can get out of one scale up from some, in theory, you're probably not going to get that much. It's just the same as when you do multi-threading and so on. You don't normally expect to get the full scalability. Try and get as many compilers as you can, actually, to have a look at different reports, see what different compilers are doing. Because sometimes you'll find one compiler can find a way of doing some vectorization where another can't, or where it thinks it can't. And then maybe you realize your algorithm isn't fundamentally non-vectorizable, but because one of the compilers has done it, and then you might find a way of actually changing your code. So here's an example from one of the nicer compiler reports, as far as I'm concerned, and that is one where you get the report from the Cray compiler. So the Cray compiler will produce you a very nice long report about all the optimizations it does, and it does this little source code and little notes and indentations about what it's done. So there, the V in that little inner loop is telling you that it was vectorized. Okay? And it's also telling you the R, how many times it unrolled that loop to get the vectorization better, to get other aspects of the code better. And if it can also, sometimes it will do pattern matching. It's a very clever compiler at times. It will actually, if you write your own matmul, which you should never do, it will just turn it into a dgem for you because it sees, well, that's a matmul. So this is just another compiler. Get as many as you can, see what's going on. That might help you as well.